Hello everybody and welcome to our product presentation. Today you will learn more about our clamp-on temperature sensor. As always, let's start with a question. How do you measure temperature levels in a hygienic way inside small pipe diameters? The challenge is that you don't want to interfere significantly with the flow of your process media inside the pipe, and you want to keep CIP and SIP procedures as effective as possible. The disadvantage of an invasive measurement is, of course, that it does interfere with the flow, and if the process conditions aren't favorable, then you have the risk of product residues remaining inside the pipe after CIP and SIP procedures. So how did we work on this challenge? What we took as a first assumption is that the pipe heats up in the same way that the process media heats up inside of the pipe. This requires a special design, of course, not only of the sensor, but also of the clamp-on block. So at first, we have the temperature sensor. There is a silver tip right up in the front, and it is shaped in a way that it fits exactly onto the outside diameter of your pipe. So you cannot use this sensor for other pipe diameters. The idea behind this is to avoid the air captured between the surface of your pipe and the silver tip. So that's where you put just a minimum amount of heat transfer paste on the silver tip to assure that. Secondly, we have a specially designed clamping block. This is a block that goes onto the pipe, is connected by two screws that go in through the bottom here of the clamping block. Now you can see this is made of plastic. Why is this so? If this would have been made of metal, then of course this block would heat up in the same way as the pipe would heat up. But what happens when the pipe cools down again? Then you still have a lot of heat energy here inside the block. And then you would not be able to guarantee, does the silver tip measure the temperature of your pipe or the temperature being influenced by the level that the block still has. So we choose a special plastic material, PTFE or PEEK, P-E-E-K, for the clamping block. This is heat resistance up to a level of 180 degrees C. So that should cover a lot of temperature levels that we have in CIP and SIP procedures. At the end, when installed, everything would look like this. You would have the pipe here, you would have the two blocks connected together, and the RTD installed from the top. By the way, there's also a special nozzle on the thread that when screwing in the RTD avoids that the silver tip rotates as well. We want to make sure that the curved tip of the sensor really fits exactly onto the outside diameter of your pipe. Now, what do we measure? In fact, as explained, we only measure the outside temperature level on the pipe. But this, of course, is not the temperature level that you would have inside of the pipe. So what we need to know is the delta T, the temperature difference between the center of the pipe and the outside surface of the pipe. Therefore, you run a trial and you define the delta T. To explain the temperature drop, if you look at this graphic, you would see that the center would, let's say, have a temperature level of 100 degrees. Then the energy travels through the pipe thickness, and then you would measure the outside temperature on the pipe surface, on the outside pipe surface. And that, of course, is lower than the temperature level that you have in the center of the pipe. But this delta, let's say it is 1 or 2 degrees, is always the same. It doesn't matter where you measure, you have this delta of 2 degrees. So if you measure on the outside 100 degrees, you know that in the center of the pipe you would have 102 degrees. So it's not about the direct accuracy of the reading, it's about the reproducibility of the reading. You have to make sure, and the design guarantees that from the GA2610, that you always have a reproducible result depending on the inside temperature level of your process media. So it's obvious, what would be the restrictions for this kind of technology? It doesn't work on plastic pipes, as already mentioned. There are only specific gases and liquids suitable for this measurement because they distribute their heat in a very firm way into the pipe material. Third point would be it would not work with vertical pipes because you would not be able to guarantee that they're always filled with process media, except of course for vapors or gases. So what are the benefits of our design? At first, a wide range of pipe diameters can be covered by that system. Secondly, it's a top hygienic way to measure your temperature levels because you're not in direct contact with your product, making CIP and SIP procedures very, very easy and very effective. There's no interference of your product flow inside the pipe, and the system is easy to install, replace, service, or calibrate. And last but not least, all components are available as a spare part, and you can keep on stock for servicing if required. So if you have any further questions, please don't hesitate to have a closer look. On our website, labom.com, there are some videos available there that additionally explain how this system works and what the idea behind this is. Feel free to get in contact with our worldwide sales partners or contact any of our colleagues here in the sales department at headquarters in Hude. Thank you very much for watching and take care.